Hello everybody and welcome to another Gear Talk. And this time I'm going to talk to you about the use of filters with the monochrome camera. In this case the Pentax K3 monochrome, but it can be the same with film or other monochrome cameras. As usual, before we begin, if you want to support the channel, please put a like, subscribe, share with your friends, and if you want to go a step further, there's the link down there. Go on my website, you can check out my books, and you can subscribe to the newsletter. This said, let's go on the topic of the filters. One of the reasons some people say it's not worth to get a monochrome camera is because without the color information, you lose some capabilities in post-processing. For example, the use of simulated filters cannot be done obviously in post-processing because there's not the color information. This doesn't mean that we cannot use the filter. As we did in black and white film, we can use the filters while we shoot the image. So we can use the filter before, not in post-processing. This is very easy to do, and we have to understand what is the light and how the light works to understand how to use the filters. The light is an electromagnetic wave. We have a lot of different electromagnetic waves. And we are used to electromagnetic waves like, for example, to listen to the radio. And that are electromagnetic waves with a very long wavelength. So in the spectrum of wavelengths, if we go to the shortest to the longest, we have on the longest side we have the radio wave and so on. On the shorter side we have the gamma rays, and we have a little portion here that is the part that is visible to our eyes and to our sensor, and is from 380 nanometers to 750 nanometers. On the right we have infrared and microwave and so on. On the left we have ultraviolet, and we go back to X-rays, gamma rays, and so on. The part of the spectrum that we can see is divided in different wavelengths, obviously, and so in different colors. And we go from the red to the violet on this side. And we can see these colors very well when there's a rainbow. If there's a rainbow, we can see the full spectrum of light divided in its colors. Or we can use a prism and see the wavelength in the prism. What happens is that the light that arrives on our subject is normal daylight. It's very nice and uniform. So we have usually wavelengths, all the wavelengths represented in the same level that arrive on our sensor or our film. If we go toward the sunset, the light is a little bit more red, so probably it's composed something like that. If we go more in a situation that is summer, Caribbean, blue sky, the light that arrives is more like that. We saw with more blue and violet component and less with red component. So this is what we have normally on our sensor. If we want to do some tricks, for example, we want to make the blue part of the image darker, to darken the sky, we can use a filter. And a filter is something that lets some light passing by and stop some other light. For example, a yellow filter like this lets the yellow lights pass through and stops all the other wavelengths. And when we have a filter, something that is important, here is just a sample of Ricoh filter that I got years ago and I use a lot. And if we want to see, for example, this is a blue filter, here we have a diagram that shows the transmission. So on the blue part of the spectrum there's a lot of light transmitted and very few light on the yellow and red part of the spectrum. Obviously, if we check another filter, for example the red filter, we see a lot of transmission on the red part and no transmission on the blue part. So what happens is that the filter limits the light that arrives on the camera, on the sensor. The filters, as we said, transmit the lights equal to its color and stop the light that is not equal. And this is evident because if we think it, we see the filter yellow because the light that we see, the frequencies that we see, the wavelengths that we see are the yellow one that pass through the filter. So if we want to darken the sky or do something like that, we can use color filters. And if we want to see how they work, I can put here this color checker, so you can see how the filter works on different colors. And for example, if I put a yellow filter in front of the camera, you can see that the yellow patches become lighter and the rest, the blue for example, are a little bit darker. And same thing, I put a red filter and the red becomes lighter and all the others become darker. So this is what happens, and you will see some example a little bit later. So when we put a filter, the filter subtract some lights, never add lights. So when we use a filter, we have to consider the fact that we have less light arriving on the sensor or the film, and we have to correct our exposure. To know how to correct the exposure is very simple. Just get the filter instruction, and usually if you go, there's always a table like this that say, for example, with the K2 is the yellow filter, you have a factor 2 to correct, so it's one stop to correct the light. If you go with the red, for example, the factor is 8, so it's 3 stops of correction. If you use the exposure meter in your camera, it's very easy to correct for the filter, because you put the filter in front of the lens and the camera will correct the exposure automatically. But if you use an external meter, you have to keep in mind that you have to do the correction. You can use the filter in front of your exposure meter, or you can just measure for normal light and then correct the exposure. So this said, here is a set that I usually do for all my tests. You have seen in other videos, here for example for the dynamic range of the K3 monochrome, and I use this set to show you the color version, the black and white version without filters with the K3 monochrome, and the filter version. So I added the yellow filter, the orange filter, the red filter, and the green filter, and you can see here all the differences in that. Obviously this is a shade that is perfect if you want to see the reaction of different colors, because you have all the colors represented in the color checker, but a real sheen can be sometimes better. So here is the real sheen just out of the windows. It's pretty representative because you have the sky that is blue with a nice contrast with the clouds, you have the red roofs of the houses and the green hill behind. So you can see the differences here again with the same sequence of filters, so with the yellow, orange, red and green. And as you can see, the difference is pretty evident. The problem with the filters is that you have to figure out how the filter will work. Especially if you use a digital camera, you can use the LCD, but if you use film, you have to think about before. And it's not always that easy to evaluate how much is the quantity of, for example, warm light in the haze. I took this picture and I was thinking to get the sky darker. By the way, I saw the mistake on the LCD, but I took the picture anyway to show in this video. And here you can see that with the yellow filter and the red filter, instead of having the sky that becomes darker, the part of the sky with the haze reflecting warm light becomes lighter. So something that you have to know how to use, and you have to learn how to use. But the fun part is that if you have to use the filters, when you take the picture, you have to really think about what you are doing. And in this time where we take too many pictures, thinking too less, I think that is a great thing. It will bring us the habit to think what we are doing and to evaluate much better if the photograph is worth or not. I hope you enjoyed this video. Let me know in the comments, and if you enjoyed it, please put a like, subscribe, share with your friends, and check out my website, links down there, so you can support the channel in different ways. Thank you for watching, see you next time.